I see
Hello,
Richard's on.
everybody. I'm sorry.
I see Richard's on.
Oh, awesome. Hello, everybody, and welcome
Yeah.
to APS Webinars. This is the fourth and final broadcast in the APS Industry Webinar Series, Activating Industry Physics Careers. The title of today's webinar is Artificial Intelligence and Industrial Physics, Potential, Progress, and Perils. I'm Stephanie Hervey, and I'll be your host for today's webinar. Thank you so much for joining us. APS webinars are brought to you as a service of the American Physical Society, connecting you with expertise of individuals who can offer insight into physics careers, educational programs, and professional development for students, working physicists, and educators. APS membership gives you easy access to valuable career information and resources like this webinar, which allows you to get your research out to the community and network with potential employers or colleagues at our meetings, and have even greater positive impact about issues that are important to you through grassroots advocacy. It can also help you connect to your community of like-minded folks through participation in our forums, divisions, and topical groups. If you're not yet an APS member, but you value all things that APS provides, we encourage you to consider joining today. Oops. APS has a new jobs board. Your next career move in academia, national labs, and industry is just a few clicks away. Browse open positions and create job alerts for new job postings. Definitely check it out. And finally, I definitely want to mention our industry mentoring program. It's a wonderful place to connect to mentors and for a place to learn about journeys and careers in industry. So definitely check out our industry mentorship program. There's a lot of really incredible mentors waiting to connect. And some quick housekeeping items before we begin the webinar. The first portion of our broadcast will be a 55-minute discussion with our panelists, and then at the hour mark, we'll have a period of Q&A at the end. If you'd like to ask a question, please type it into the Q&A panel, which you can access by clicking the button on the lower right-hand side of your Zoom webinar. You can adjust your audio settings by using the button on the bottom left of your window. You can also turn on live captioning on or off by clicking the arrow next to live transcript. A link to the recording of today's presentation will be made available on the APS webinar homepage within 4 to 5 business days. Also, as you leave the webinar today, we encourage you to complete the survey upon exiting so that APS webinars can improve its ability to provide you with these valuable services. And so with that, we're going to go ahead and get started. We have some incredible speakers lined up today. We're super excited to bring these folks to you and for us to hear this conversation about AI in the physics community. And so we have Ray, a research scientist from the Toyota Research Institute, specializing in physics-infused machine learning algorithms. Dr. Lee focuses on acceleration of materials, simulation, and design, and his research aims to improve energy devices such as batteries, fuel cells, and driving a more sustainable future. Sarah, we have Sarah here today as well. She did a PhD in particle physics at the University of Washington, and she did not find the Higgs boson. She moved to the UK for a PwC graduate program to help her transition from academia to business. Since then, she has worked on consulting and financial services, including using data science to fight financial crime in one of the world's largest banks. She currently is the head of AI at the Citation Group, which provides professional services like HR and health and safety advice to small businesses. Daniel's also with us today, and he's a third-year postdoc fellow at Sandia National Lab, where he serves as the Quantum Performance Lab's in-house expert on machine learning. Daniel's primary research focus is on applying classical tools, e.g. statistics, machine learning, and deep learning to better understand noisy quantum computers. Nabil, oops, excuse me, that's getting ahead of
Can't
myself
forget
here.
Nabil. Hey,
That was a great picture. Nabil is the owner of Solve Reality, a tech entrepreneur focused on leveraging artificial intelligence to accelerate discoveries in the natural sciences. And in his prior lives, Nabil served as a senior consultant at Bose Allen Hamilton, advising government clients on large organizational change initiatives. And finally, Richard Galvez is the lead AI scientist at Percipio Health, and also the CEO and founder of Spark Grid AI Consultancy and the faculty lead for NASA's Frontier Development Lab. He has deep expertise in developing and deploying machine learning systems from end to end, with a proven track record of leading innovation teams from academia to startups to Fortune 100 companies. Oh, and finally, our incredible webinar moderator today is Peter Fisk, and we're just so happy to have him. And he's from the National Alliance for Water Innovation and comes to us with more than 2 decades of experience leading technology organizations and initiatives across industries such as water, renewable energy, defense, and natural resources. And with that, Peter, I'm going to let you take it away.
All right, Stephanie, thank you very much. And welcome everybody to today's open panel discussion. I want to remind you again, as questions come to you, put them in the Q&A. And then at the end, we'll have at least 15 or 20 minutes to do Q&A from you. And you can ask questions directly to each of these wonderful people, or we can pose it to the group as a whole. So everybody, it's great to meet you and to talk about this exciting frontier in science and how we basically do everything. So I guess I'd like to start, and I'm just going to go on the Hollywood squares and ask each of you very briefly to, we know your organization, Stephanie's given an introduction, but tell me a little bit, first of all, Nabil, what is your organization, and how do you interact with AI on a daily basis? Or what role does AI play in your particular kind of daily activities? Nabil, you start.
Sure, happy to. Well, nice to meet everybody. Thank you for coming to today's webinar. So I am Nabil. I'm a blogger and keen observer of the AI for physics space. Unlike my esteemed panelists here, I do not have a PhD. In fact, to be totally honest, I struggled in my physics classes in high school. But I do think that this is a really interesting place to be working in. And I've spent, especially this year, as I've been exploring AI for science, volunteering for organizations like the National Science Foundation's AI for Physics initiative called IFI and others. And through that, I've had some really great conversations with physicists, postdoc researchers, and so forth about the kind of trends they're seeing, how they're using AI to advance their work. And also, I've been just paying attention to where the funding is going and where sort of the investment's going. I'm personally using AI in really helping me to make sense of areas that are outside of my technical expertise. I'll go when I'm looking at a paper or going to a blog or a write-up or an event. I'm often taking quotes or paragraphs, putting it into a large language model and helping me translate that. And I think that's been really helpful for me as a way to lean in to a field that's new to me and start to build connections and relationships. And I think what's really cool is that's happening also at the upper echelons of folks who've got a lot more technical knowledge than me, being able to help them collaborate across silos more effectively. So happy to go more into that, but that's a quick introduction.
Great, thank you. Sarah, how about you? So tell us a little bit about what you do in your organization and how specifically you're using AI on a day-to-day basis.
Absolutely. So I'm new in a role, and I'm in a newly creative role because the companies recognize the disruptive and exciting potential that AI has for all sort of knowledge and service-based businesses. So at the moment, we're looking at ways to sort of improve on what we already have. So we're looking at optimizing business processes, delivering code development faster, creating content faster, translating things, putting things into our tone of voice. There's lots of ways to sort of improve what we're already doing. Then the longer term view that we're going to take a bit of an innovative approach is then how can we use AI to help us develop new products that will help serve our customers' needs better. We help customers with all sorts of compliance issues. So how do I deal with HR? How do I deal with health and safety? How do I deal with risk assessments, et cetera, et cetera?
Great. Fascinating. Ray, how about you in Toyota? Tell us a little bit about how AI is touching Toyota on the research side and how it touches you on a day-to-day basis.
Yeah, absolutely. And first, I'm very happy to be here. Thank you for the invitation. So yeah, I'm at Toyota Research Institute. So it's sort of children of Toyota Motor Corporation, and here we do more fundamental research related to robotics, self-driving, and many other things related to, you know, automobiles and other energy-related things. So for me, I'm in this team called Energy and Materials. So our team mainly focus on, you know, how to leverage the new tools that we have, AI simulations, to discover new materials in the future for not just for cars, but many different things in the future. We also use AI to kind of understand what we have right now, like in the energy industry, right? You know, how to understand fuel cells, batteries, how do we optimize them in the future, and we also actually use AI to understand the business, like the whole industry as a whole, right? Like, because we know there's a huge push from the society to carbon neutrality within decades, and you know, how do we do that? We used a lot of AI tools to understand that process.
Great, thanks, Ray. And that materials discovery is something we also do at Lawrence Berkeley Lab. We'll talk about that a little later. Daniel, you're over at Sandia over in Livermore, California. Tell us a little bit about, you know, we know Sandia National Lab, but tell us a little bit about how you see AI working both for you on a day-to-day basis, but also how it is also potentially changing how we do scientific research.
Yeah, of course. And of course, thanks for having me as well, Stephanie and Peter. So just to provide a little context for some of the participants, Sandia National Lab is a national laboratory. So our customers is really the US government. So at the lab, we have a pretty broad ML and AI research program that is focused on sort of tackling problems that the government cares about. And broadly speaking, those include things like trusted AI. So understanding how can we sort of evaluate and trust the decisions that AI is telling us to make, or, you know, the research that we want to use AI for. It also includes sort of hypercharging, large-scale modeling, and sort of developing better quantum computers, which is what I use machine learning for. So in a very focused sense, I use machine learning in my research to understand a quantum computer, which is a sort of very delicate, large scale, and difficult to understand system, despite the fact that it operates at the quantum level. And we're really interested in sort of allowing machine learning to understand the device for us so that we can then make better devices. So we use sort of classical machine learning tools in a feedback loop to continually improve the device. And yeah.
Great. And finally, Richard. Richard, where are you today?
I'm actually at the NeurIPS conference in New Orleans.
New Orleans.
So
okay, very good.
Yeah, it's so this is actually a big AI conference that goes on every year.
I think is Ray. Ray, are you there too?
No way, really? Oh, good. Okay, great. Maybe we can meet. And
yeah, guys,
talk about...
grab a beignet afterwards. That's awesome.
Oh, beignet, yeah, of course. Great. Yeah. Well, okay. So I perhaps have a bit of an assorted background, I think, considering like the panel. So I left academia as a postdoc in AI, like meeting astrophysics field, kind of how AI can help us understand more about astrophysics and physics can inform AI. Back in 2019, I was at NYU Center for Data Science there. And I went into industry then, and I found myself kind of figuring out my role in industry is kind of coming in somewhere and starting something from 0 to 1. So starting from complete sort of blank slate and building something from the ground up. So in my most current iteration of that, I'm working at a Percipio Health, as you mentioned earlier. Yeah, you pronounced it correctly as well. Thank you. But yeah, the main gist of what we're doing at the moment is applying language modeling and what's called mixture of experts models to inform and help clinicians maybe see the blind side that they didn't see when they're considering a diagnosis, or what's called clinical decision support. But really, that's just like an application of what I'm currently doing. I mean, I really enjoy the field, but I've seen kind of my career will evolve really on just what's someone currently trying to figure out that's really difficult and complicated and math heavy, and that's where I live. I think.
Cool.
Yeah, but how AI affect over how I interact with AI on a daily basis? Boy, as much as possible, I think. I think is the answer to that one. But yeah, also dealing a lot with large language models, generative models in general. I read a lot of papers, keep up with the field, kind of had to understand like what's happening and whatnot. And at time to time, I will ask ChatGPT for its summary of a paper if I'm, like I don't necessarily understand something or don't feel like reading the whole thing. But that's about it. Yeah, I mean, it's a quite a general tool.
Yeah, very good. Well, great, everybody. One of the things I was listening to a podcast recently on this sort of frontier of AI, and one of the areas that they mentioned was that there have been actual trials with people writing code with AI assistants versus without, and it is dramatically more productive with that assistance. So, Richard, that definitely squares with your experience, right?
I mean, 100%. I pay I forget it. I think it's $10 a month or something for Google for Copilot and VS
Yeah.
Code.
Yeah.
Highly, they have a lot of very
And you're
liberal
like
academic
twice as fast
licenses.
now. That's awesome.
Yeah, or I'm like, oh, I don't remember how to write that silly bash script that like will delete all the files that like have this regex like
Yeah.
so I just write a comment. The following lines of code does this thing, and then it just will do it for me. And I'm like,
So,
that saved
yeah.
me about an hour. Yeah.
Yeah. Yeah. Sarah, you're smiling. So where do you see a similar kind of like kind of big leaps in productivity?
Yeah, absolutely. So, I mean, it's all over the business. So we have enterprise Copilot as well, and we've done some pretty rigorous studies with teams, following an agile methodology, sprint velocities, if you know that language. But we're seeing estimates from 10 to 30% in productivity that we can measure depending on the task. It's been a huge deal.
Yeah, that's great. And it also helps that it's stuff, as you said, Richard, it's kind of like, this is tedious. Get me through this, help. And like bang, it's there. That's awesome. Ray, you had mentioned something I wanted to get back to, and that is that aside from like the kind of workflows that we might engage in and ways in which decision support and AI assistance can really speed us through those, you also talk about the frontier of actual discovery. So can you tell us a little bit more about the world of kind of material exploration using AI?
Yeah, there's a huge push in recent, let's say like a recent decade, in using material science, like in using AI, data science related tools to push the frontier for kind of material discovery in the future, right? And that started like we started using like graph-based models to model. So for me, I'm more interested in custom materials. So we use graph-based model to model those materials, understand them, and use some outside loops like active learning, like all those kind of things to try to discover new materials in the future. So there's actually a interesting, I think, big news from Google and Lawrence Berkeley.
That's
I think
right.
just 2 weeks ago, they used exactly this kind of model, this kind of workflow to discover, I think, hundreds of thousands of virtual materials, and they were able to synthesize using robotics, right, automated labs within a couple tens of days. So that's a huge leap, I think, from what we had before. That's a really big advancement recently.
Yeah, so at Lawrence Berkeley Lab, on my research program, we basically were able to discover a novel catalyst that is a cheap catalyst to replace platinum in a set of water treatment applications, and yeah, it's remarkable. So this area of we have this frontiers where it's affecting us in our daily work, and it's also affecting sort of how we do science. Does anybody else have any other examples of how the scientific process might be accelerated with AI? And Daniel, maybe you have some thoughts here about how we may be doing science differently or research differently with AI.
I can at least talk a little bit about how, artificial intelligence and machine learning is impacting quantum computing as a field. So like I said, quantum computers are these sort of large, complex systems that once they get sort of large enough, if you want to develop, it becomes kind of impossible to develop like a digital twin model of a quantum computer. If that was possible, there'd be no point in pursuing the quantum computing research program to begin with. So think there's a lot of hope, and this is in part what my research program is about, is building machine learning surrogates. So not truly faithful digital twins of these quantum computers, but using machine learning and especially neural networks because of how sort of powerful they can be as surrogates, so that you can answer questions about this complicated, hard to describe physical system in a very targeted manner, without necessarily expending all of your computational resources to understand it, but also without necessarily digging super deep into the physics.
Yeah.
So I think there's machine learning can help you black box some stuff, which can sort of accelerate your research program pretty nicely.
Yeah.
With that being said, you can only black box so much, right? I think that maybe we'll talk about it later. Machine learning without sort of informed domain knowledge, especially in a field like physics, only takes you so far. And you see things like physics informed machine learning can really outperform physics agnostic tools that are developed.
Yeah, totally agree. And Nabil, you sit sort of as a journeyer and a kind of exploring all this landscape simultaneously. So, what are your kind of observations about how the process of doing science is undergoing some revolution here?
Well, one story that comes to mind is I was talking with a theoretical physicist who was telling me that in his perspective, all of the machine learning methods, whether it's graph networks, transformers, diffusion models, are helping him in his research, maybe with the exception of reinforcement learning. So when he's looking at data coming out of, say, the Large Hadron Collider, so far the Large Hadron Collider has spit out an incredible amount of data. 100 petabytes, I think, is the estimate. So that's 100 million gigabytes. And being able to sort through all of that data is a very arduous task, but also one that's really perfectly built for AI and ML methodologies. And so some of the things that he's saying that's helped him with is, whereas previously when they took data, they would have to compress it, which then has, effects on their ability to make or get good insights out of it. They're able to do now more what they call unbinned research. So looking at larger sets of data at the same time. It's helping him with anomaly detection. So when something is happening that maybe is unexpected in the data set, potentially that's a pointer to some new physics emerging. And so some of the machine language model that he's built for anomaly detection, again, have been helpful in his process. The last bit is a lot of his work is simulation based. And so being able to do these simulations and run inference on these simulations by drawing these techniques has allowed him to speed up that process as well. So I think especially for these very data-rich applications, it's been a real godsend for him.
Very good. And everybody, welcome to our session here today. I want to remind you that put your questions in the Q&A. It's also great to hear from you on chat, but the Q&A, that's how we're stacking up the questions, and we'll answer them after we have our session with today's panelists. So Sarah, you're in a consulting space, and one of the questions that a lot of kind of early career physicists ask is like, well, how can I position myself for a transition to a data science or an AI career? But I guess my question to you, Sarah, is there such thing as like an AI job or an AI career? Like, how would you all kind of describe this issue? It's sort of like a tool that can be applied in lots of different landscapes. So Sarah, I'll go to you first. Is AI a career path?
My job is head of AI, so I guess so.
But that's right.
No, I mean, I really started doing this stuff back in my physics research. I started with the more sort of fundamental machine learning. I built my first neural net detecting B quarks at the D0 experiment, which is one generation before the Large Hadron Collider. Turns out that stuff is actually really useful in industry. And I didn't even know it was like cutting edge technology at the time. I just thought, okay, this is how I do physics research.
Another job, right? Another tool.
Yeah, okay. If I have to learn this algorithm, then great. But it turns out there's huge value for that in the industry. I work for a physicist. I have another physicist who reports to me. I've worked with many physicists throughout my career, particularly in financial services. So I think physics is such a great starting off point for getting exposed to this technology and being able to say, okay, what tools do I have available to solve a problem? And I think that's what I've learned from physics and what I love in other physicists. So I think taking those skills and pointing those in whatever direction you find interesting, that's that's the career. We don't know where this is going to go in the future. AI popped up as a term about a year ago, really, in
Isn't that
earnest.
crazy?
It's
Yeah.
been around since the 1950s, but then suddenly, boom, last year. So ride the hype wave, I think, is part of what I'd say.
Richard, what are your thoughts about, like, you're reflecting on your career? It's intimate to the work that you do and the value you create in multiple settings. So, is it a career, and how does one pivot towards it?
Yeah, great question. So first of all, I do think that right now we are kind of in an AI revolution that is akin to, say, the 1920s, 1930s quantum mechanics. Like there's just discoveries that are happening all the time. And I'm just being at this conference, seeing like some of the recent developments and ideas, and it's just kind of like, wow, this is just exploding right now with just all kinds of really intelligent people trying to figure out really hard problems. So, I thought a lot about this kind of question too, and preparing for this panel. And I think in general, people typically look to physicists as just people that understand some complex materials that they could maybe recruit to their hard problem to help them solve some difficult thing, whatever that might be, whether it's submarine detection or whether it's virtual doctorization or whatnot. But I would say that, I mean, it's what's quite interesting about AI is that really you could think of really cutting edge AI as like quite general function approximators. And so really it's a field of applied mathematics meets data somehow. And there's these neural networks that somehow are able to model functional behavior. So this kind of field, I think, is really like having a physics background definitely helps you. And I think you're really well suited to mostly people, I think, that come from, well, I think physics in general really prepares you well. Like I was looking at a graph yesterday that reminded me of an Ising model, for example. But I will say one cautionary point though to those people that are looking to quote unquote pivot or so really accept it as a career transition. It is a career shift. It's a different role. I think people really want, I've found, to use your skills in physics, but they don't know it necessarily. Like they don't necessarily know how to identify that you do bring those abilities. So that's a challenge that I don't necessarily have an answer for, but I would like to put that out there for people that sometimes it's hard to read us, I think a little bit. You've already kind of if you're leaving the academic route in particular, I would say you're kind of choosing your own adventure in the industrial world, and you have to kind of redefine yourself as you go and help people understand who you are. Even it's not a trivial problem, I would say.
Yeah, I'd agree. And Richard, this idea of pivoting from the familiar world of academia and research to these industries that are every bit as complex, but we have very little background. One of the key things that we talked about earlier in the session this fall was the critical need for doing informational interviewing and spending time talking to people in the space just because you're curious, and just simply not just getting advice, but just getting some degree of insight and orientation as you consider your journey. Daniel, you're in the scientific world, and we talked a little bit earlier about how you're literally seeing the ability of AI tools to make these somewhat, horribly complex and horribly inexplicable discernible. And I'm sort of curious about your background. So did you have AI as a component of sort of your activities back in grad school, or kind of when did you first recognize that this was a tool that was salient to the work you wanted to do?
Yeah, thanks for throwing this question my way. So I am not a physicist actually by training. So in the last 3 years, I've simultaneously pivoted my career in two ways. I am now a physicist who uses machine learning. In grad school, I was a mathematician. My PhD is in pure mathematics. I studied abstract algebra. and it was all very pen and paper work for me. But about halfway through my doctoral program, I realized that I really wanted to do work that was more hands-on and more interdisciplinary, and that I felt was making more of an impact or had the potential to make an impact on the world. So I sat down and sort of looked at what were the fields that could sort of use someone with a mathematician's mindset, with that sort of training and thinking very, very formally and thinking very, very rigorously and sort of step-by-step working through problems. And I came to machine learning and quantum computing as fields where I could really make an impact. And I spent 3 years really doing a lot of self-studying, as well as taking classes that were just independent study classes at the university. And also, like you said, Peter, doing lots and lots of networking, doing informational interviews with people in industry and with people at the labs, not just to sort of learn, not just looking for a job, but really looking for where can I specifically place myself in this field to help transition, to help make the transition easy for me. And sort of also thinking about, well, what are the jobs in these fields that I would really enjoy doing? Because these informational interviews are really a two-way street. You know, you want to learn more about them, but also where you could sort of what your own interests are. And I found a lot of success in really selling myself as a self-starter who was curious and really interested to learn. I think people in industry and sort of even in academia really enjoy that. And what I found was that I wanted to use machine learning for research. That was really what motivated me. I wanted to tackle difficult problems in science with machine learning, and I'm fortunate enough to do that now. So I don't think I exactly answered your question, Peter, but hopefully I tied it to the bigger question.
Yeah, and I also appreciated the journey, and I think the thing is, like, you look at these new disciplines, you're like, oh my God, where do I start, et cetera? And the answer is you start at the first step, which is maybe even a simple initial conversation, or in fact, attending a webinar by American Physical Society. So these are the ways in which we begin a journey. And Ray, I'm curious about you. So when did you, in a bit with your technical background, when did you kind of encounter the AI and the insight that this is going to be important for me in the work I do in the future?
Yeah. So my background was I'm a chemical engineer by training. So my background coming out of undergrad was in computational chemistry. So going to grad school, I was really just trying to figure out what I want to do, right? And then my advisor, who was just starting, kind of introduced me, let's do something about quantum mechanics, density functional theory. Can we improve it somehow? And I was like, how? What do you mean? He was like, okay, back then was actually the time when convolutional neural networks are just taking up speed. So he was like, can we think about combining them somehow? Because when we think about it, electron density, that kind of map, it's just a 3D picture, right? It's an image. Can we use that tool to use the data science tool to understand this new kind of problem in quantum mechanics? And that's how it took up, right? So from there, I started to kind of trying to figure out ways to combine science and machine learning to kind of enable both in a way. And that's when I started to feel, this is really going to be really important, because back then we have a lot of data. Before this time, we have a lot of data, but we don't really know how to deal with that. And now there's a tool, right, telling us, okay, this is what you can use to kind of enable better and more, more advanced in the field you're research on. So that was grad school. Then going to industry, I think there's another transition for me because then I realized maybe it's just the institution I'm working for. There's a huge push in using like AI and machine learning to do like fundamental research, right? All the questions we ask, we all just turn it into machine learning. Can we do something about it using exactly machine learning tools? So that's where I was, even with a little bit, machine learning experience, I was still shocked by how much this institution is invested on machine learning and AI. And I think it's a really rightful way of doing this, because we do fundamental research, and AI and machine learning, I think it's gonna change the way we do research in the next few years and decades, for sure.
I think so too. And Nabil, so you're an example of somebody who is literally journeying and literally having these conversations. So I'm gonna, instead of telling you kind of the general journey, I'm gonna ask you, Nabil, tell me about one of the conversations you've had in this last year that has really blown your mind or changed your perspective about where this field is going, what its potential is.
Oh, wow. Well, a couple of things come to mind. First, if I may actually contribute something to that last question about moving into physics,
Yeah.
to AI ML. So
Yeah.
the first is just a quick point that I wanted to contribute is, as maybe a word of encouragement, as a physicist, you are equipped with a superpower when it comes to this field, which is you are really well versed in understanding complicated systems, breaking them down into small parts and getting an intuition for how they work. And that's so important for especially a lot of the challenges that we have now around things like explainability and managing hallucinations from these systems. Some of our breakthroughs in machine learning, such as diffusion models, come from having an intuition around thermodynamics in physics. And so, what I would encourage you, and this is also to your point, Peter, about starting with the first step that I took, is there's a lot of really great courses out there. I took a Coursera machine learning specialization, $55 a month that I could sign up for. I spoke to a math PhD who was now moving into the physics space, who was saying he went through a practice of finding papers that he thought were really interesting and trying to replicate them on his own in combination with some coding classes. So I just think that the field is wide open, and there's actually, I think, a lot of specific interests in the skill sets that you bring. To answer your question about something that's blown my mind, I think what I'm really excited about is, I'm hearing from folks as there's now this topic of developing more generalized intelligence and this sort of boogeyman / interesting concept of AGI. So models that can really generalize across different modalities and start to develop more sophisticated reasoning capabilities. There's often a question of what's the right test for these models. And I think one of the things that I've heard is, hey, actually finding new physics, discovering new physics, that might be the penultimate test of whether or not we've actually achieved AGI. So I'm really excited about that, and that blew my mind.
That's awesome. That's awesome. You also, Nabil, you raised an interesting point that we haven't really talked about, and it's natural in the excitement, especially with us, so many of us being kind of like technological and honestly kind of like techno-optimistic, technophilic, to think, oh, this is just unbridled good is going to come our way. But you mentioned the issue that these models can behave kind of weird. They can hallucinate, and you can also get into an issue of a little bit of are we getting into a place that's going to be potentially ungovernable? And so I would say, like, Sarah, as you think about this issue, are there boundaries that you are sensing where some of these AI tools may need some additional forethought before we just deploy them willy-nilly? What are some of your thoughts there?
Yeah, I mean, we definitely talk a lot about the risks that are possible with AI. I think, especially when using the open source, the chat GPTs, you have to think about don't put any sensitive information in there. You have to think very carefully about hallucinations. It will be very confidently wrong sometimes. That's a huge risk.
I have friends like that too, by the way. So
I know,
yeah.
right? We've all been
Often
to
an
that dinner
error, but
party.
never in doubt, right?
Yeah, but it will. And I think we're probably not used to challenging text as much as we're used to challenging a human in that way.
Yeah,
So I think those are big risks. Obviously, another big one that comes up is bias. And so especially if you're using AI to make decisions about something, especially make decisions about people, it will have learned from data sets which are potentially biased. So an interesting example that I often use is I used a photo app, much like the one we use to generate our promo images. And all the pictures I loaded in of me had glasses on, and most of the images I got back didn't have glasses because the underlying model had been trained on model humans who weren't
Most
wearing
people.
glasses.
Right. Yeah.
So anytime, you're in a situation, yes, we can think about all the scary isms that we need to worry about, but also something simple as what training data have you put in? I think it becomes a bigger issue with generative AI, even more than sort of classical machine learning.
Yeah, very good. Anybody else have an experience like that, where you're thinking of frontier you need to be more thoughtful about the underlying structure? Richard, do you have any thoughts there?
I think I just echo what Sarah mentioned. Like it's a super real problem. But also I like to say that it's hard, but it doesn't mean that we shouldn't do it. Right. And like there's some really interesting work going into understanding bias and trying to figure out how to get around it and whatnot. But I do echo that same concern. Like there's a lot of work looking at like guardrail, large language models or guardrail systems in general that try to get around this. But it's a hard problem. But if anyone is going into this that's listening, be very careful. Yeah, it's probably the best advice I could say.
Um, Daniel, you're in a space, you're using this tool in a space that is itself novel, where you're building these quantum systems and you're developing, you're taking measurements, you're sort of essentially developing the data that you're then going to throw into these models to try to interpret. Any advice about how we judge the underlying data upon which we're building these tools, or any other kind of concepts about like where we should, despite our optimism, have some discernment about these tools?
So I am fortunate enough in my specific research to deal with relatively clean data. We're going out and doing controlled experiments to generate the data that we're training models on. So in my day-to-day life, we actually have a ton of control over the data that we're gonna put into these models. And what that means is we spend a lot of time thinking about the data sets that we want to generate. We want to make sure that these data sets aren't biased. Now, the consequences of being biased here are a little different. We're sort of controlling probability distribution so we can get good generalizability. But I think that at a very niche level ties into sort of the broader discussion of bias. So I would say that, yeah, the question of bias has broad societal impacts, but it also has impacts for sort of the specific research that the researchers do. In the past life, I worked with data sets that were not clean at all. And I think it's good, especially for people who are thinking about getting into AI, ML, or even data science, to understand that when you're out in the real world, a lot of the time you spend doing machine learning or doing data science is actually doing data
cleaning,
data gathering,
right,
and data cleaning. And it's not glorious, it's not glamorous, but it's sort of vitally important building good models.
Yeah, and in that respect, I couldn't agree with you more. And also, really, in some respects, getting back to some of the theme of today's discussion is like we're talking to a community of physicists, many of whom on today's call and the participants are early career physicists. And one of the key things that comes with a physics or a science background is this idea of constructing models, and then also the very thoughtful assembly of data themselves, and a thoughtful understanding of both quality, veracity, and relevance of those data. I want to kind of say that we've talked about it, various members here on this panel have talked about the just incredibly exciting moment that we're in. This is like the Cambrian explosion. This is like an amazing thing, but I guess it also is going to produce a lot of stress. And I would say stress on industries, stress on individuals, and stress on situations. And so I'm going to like maybe ask each of you, what you think some of those potential sources of stress might be, either in your organization or in your career or in an industry. And I'll start with you, Ray. What you think this is this kind of field's going to create in terms of stress or friction?
Yeah, it's an incredibly fast-moving field, right? And it's so hard to keep up with. I think yeah, especially during the past few years, I think the speed of the discovery is just like astronomical. It's just impossible to keep up with what's going on. I'm in a conference right now, and yeah,
You're
it's
probably
just like,
hating being here, spending the hour. You're like, I got to get back to the talks.
that's not true. That's definitely not true. I love but yeah, it's hard to keep up with. I think that's most of the where my stress comes from.
Mm-hmm.
And like also like as a institution, as a society, we're also like to me personally, I think AI machine learning it's a tool, right? It depends on how you use it, but it's an incredibly powerful tool. So how to really use them in a responsible way, in a how to say in a control way, responsible. I kind of echo back to what Sarah and Richard was mentioning earlier, right? So there's a lot of potential downfall of AI tools, right? Like hallucination, like this instability going outside the training domain. How to really control those is I think it's a big concern, not just from me, but also within the institution and also probably from the whole AI for science society. And as scientists, I think we should be extra careful because science sometimes needs that kind of precision that's not cannot be provided by just data driven kind of models, like just out of the how to say like vanilla sort of say some kind of machine learning model. So we really need to be careful there. How do we really use our knowledge as physicists, right, to really help improve those models and to do like real kind of science discoveries in the future?
Yeah, thank you. Sarah, where do you see potential locus of friction or stress as this technology continues to promulgate?
Yeah, I think people are worried about their jobs, right? People are going to think, oh no, is my job going to be automated away? Especially now in sort of knowledge and service-based industries, there's the potential for huge disruption. I don't think that's necessarily going to happen. I think jobs are going to change significantly in the same way that jobs changed significantly when the internet became a big deal, when search engines became a big deal, right? We didn't have search engine optimization before there were search engines. So I think you're going to see, yes, some jobs are probably going to disappear, but I think you are going to see more AI jobs happening as well, or jobs that are heavily using AI to just automate away those points of friction as well.
Yeah. Nabil, points of friction, and also how does the rest of the economy, the people who are not specifically seeking AI, explicitly, how will they need to think about this, and how will they need to react?
Sure. Well, one point of stress that came up a lot in my conversations with practitioners, especially in academia, labs, and smaller startups, is really one around resource constraints. So one article that I read this year from MIT Sloan in May of this year said that 70% of people with a PhD in AI get jobs in private industry compared with 20% 2 decades ago. So there's a giant, I think, sucking sound of folks with talent that are getting sucked into private industry, which also has the resources to buy things like compute and GPUs and so forth, which is already scarce on the market. So I think, yeah, for folks in those positions, trying to figure out how to compete, where to get talent from, if that talent is coming from abroad, how to deal with, especially if you're working at a lab, some of the security clearance challenges around that as well is stressful. I think the good news is, or maybe the sort of silver lining is, it's also forcing organizations to do more with less, and especially like less compute. And so you're seeing the emergence of things like equivariant architectures, which allow you to, with less data and fewer parameters, create models that are faster to train and to run, which benefit the whole industry. I think, the personal advice that I give myself and I would give anybody, I think, especially if you've got small kids, is I think the best skills that we can teach ourselves and others is the skill to adapt. I think everything is moving so quickly and so unknown, and is so unknown moving forward. But I think the ability to stay curious, have a learning mindset, use the tools that are out there to try to build some sort of skill set that's relevant in that space. I think that's now sort of table stakes for all of us.
That's great. That's great advice. Daniel, you are in the National Lab world. Where do you see the potential places for friction or stress as this capability gets promulgated?
Yeah, so I'm surrounded by work that goes towards national security. So maybe it comes as no surprise that I see kind of the geopolitical consequences of AI as a massive source of friction. It contributes the race to AI contributes to economic tensions between the United States and China, and the sort of rise of misinformation and disinformation that you can just continuously pump out very easily with large language models or with diffusion models, can have sort of it allows either state actors or state adjacent actors to have pretty outsized effects on things like elections in democratic countries. And so, yeah, I think that's a huge challenge that we're going to face over the next 5-10 years. And it's not necessarily a challenge we haven't faced before, which is sort of heartening. Like I think Sarah mentioned earlier, sort of the rise of the internet had a lot of similar consequences. And even going like further back, the rise of the printing press allowed for the spread of propaganda at like rates people hadn't seen before. And the rise of sort of periodicals in the 19th century led to a lot of the same issues that we currently have with misinformation and disinformation. And sort of, I understand the analogies maybe seem a little loose there, but I think when you turn to the humanities and you look at the research there, the problems are pretty similar, and we're fortunately able to stay together as a society moving through those technological disruptions. So I hope we'll move past it, but
that's great.
Big challenge.
Yeah. Now, Richard, you're working in an organization that is directly addressing the medical profession, and so you think in particular about one area where the gathering and the use of data and then the judgment needed to make a decision. This is probably going to be an area very ripe for improvement, but also for stress. Do you see potential pinch points or stress places in the medical profession?
Yeah, I mean, all I have to do is look left and right and up and down. Yeah, and I see points of stress for me in that particular field. But yeah, it's true. I mean, so in working with this kind of data and having this kind of approach that we're taking in our world is applying working with large language models and whatnot in this space. It's one that one has to be very, very careful about, certainly. And it's stressful. I mean, I consider it to be as like, the lead person kind of building something that I think could really impact. I believe it could impact millions and millions of lives in a very positive way today, right? How to do that, in such a way that it could negatively affect someone's life, right? So, I mean, that's a stress I feel personally to the people that might be using the tools that we develop, down the line, or that I have direct impact on making, right? But that's a personal stress. I look forward though to there was some I look forward to a little bit towards regulation from the government on this, not just a blanket LLM sort of regulation, but there was some very concrete recent moves by the Biden administration where they set out guidelines for um, things that should be addressed responsibly in AI in healthcare, which was things like so looking at bias, different sources, how to mitigate them, how to address for them. And so I think what they're doing now is setting the kind of moving the first chess piece forward and saying, we suggest there should be policy here, or rather there was a think tank that put this together. And now I look to the government, the federal government, to react and create guidelines for people like me to follow very diligently and carefully. So that could be a source of stress. Yeah. I mean, I guess going back to that original point. Um, but then also kind of harping a little bit on what Daniel mentioned is I do also see I wanted to add a little bit to that point as well, where I think right now it's all kind of shiny and amazing and kind of incredible what things are what things are happening. But as algorithms continue to develop at a frenetic pace and we get better and better, I think that we're sooner or later going to begin to design very intelligent systems that rival humans or maybe even surpass them like dramatically. So then I wonder how as a society we're all going to kind of deal with intelligent
Cope with
agents that
that.
we created. Yeah, cope with that. How are we going to cope with that?
Yeah.
How are we going to the alignment problem? I mean, let's not get too philosophical here. But things of this nature. But yeah, I think going back then to your other question about healthcare, yeah, I look for policy to help regulate in very specific ways, not just in a blanket regulatory way. However, I think every like specific fields will have to be regulated very specifically. And unfortunately, I think there are going to be some they're just kind of in the field of innovation. Sometimes oftentimes regulation follows after something bad happens. I think so. I think it's unfortunate something is going to happen, but what it is exactly, it's yet to be seen.
Yeah, and I'll note, Richard, that for example, this issue of policies is its own very burgeoning space right now, and a lot of great discussions. The American Association for the Advancement of Science, AAAS, has their science and policy technology fellowships, and they started on a very short notice a cohort of AI fellows to come into Congress and to come into some of the agencies to help, because there's just such a dearth of the frontier is moving so fast. So for those of you on this call, do check out the AAAS fellowship program if you've got AI and ML background or experience and also really interested in policy. That is a very interesting pathway to consider. Okay,
I'm gonna. This is my stress. Yeah, thank you for
yeah,
telling
exactly.
me about that.
Yeah. So, hey, well, check it out. It's a great program. It's been running for
Peter,
60 years. Yeah.
If I could, I just wanted to add to that. Richard mentioned what the Biden administration has sort of done with AI, but this is a global problem, and I don't think we should forget about the AI Act that is making its way through the European Union, and
right.
is a problem that we kind of need to solve globally.
Yeah, great point. Thank you very much. So I'm going to pivot to sort of specific advice for our audience. Imagine many people listening in today are early career physicists, science background people, and they're thinking about how do I make the pivot? Who do I talk to? But I'm going to go to each of you, and I'll start with Nabil first and say, is there one thing, if a student or an early career physicist has a little wedge of time, what's your one advice for what they should invest in, either in a particular resource, if you know it, or just a general practice for them to get traction in this space? Nabil, what's your advice?
So if you haven't coded before and want to understand a little bit more about how that works, or even machine learning, one resource that I really enjoyed using was Kaggle. That's Kaggle. It's a startup that was bought by Google a few years ago, and they've got these really great bite-sized, almost gamified modules where you can learn a couple of coding concepts and then apply it and actually build something, which gave me a sense of accomplishment and made me want to continue. And I think within a couple of weeks, with a couple hours here and there per week, you can get a sense of what it is actually mean to create something in code or to build a model, and give you a sense of, hey, is this something that I'm interested in diving deeper into?
Cool, thank you. Sarah, if you had advice for like one increment of investment in time or practice or something, what would you recommend?
I recommend something really hands-on. So I'm a big fan of, Kaggle's a great resource. There are also paid ones like DataCamp, Code Academy. But there's also just come up with an idea and play with it and ask ChatGPT to help you. And I think there's just no substitute for being curious and trying to apply that in the real world.
Yeah. Great. Ray, what's your thoughts?
Yeah, I would like to echo what Nabil and Sarah just said. So I think something hands-on would be really nice, especially I think if you are doing research, many of the problems in your research might be benefited from some of the simple tools from machine learning, right? So maybe just get exposed a little bit what's out there and try a few of them in your research, or like in on Kaggle, they have like small bite-sized kind of problems to solve, yeah, to get the exposure. And maybe once you get more experience, you can probably think about an internship or something in the industry to kind of really get the sense of what's happening, how people are using these kind of tools in the industry.
Yeah, great. Daniel, any advice or specific resources or specific practice for an early career person who wants to explore further?
Yeah, I mean, I think if you only have a little bit of time, code is the way to go. But assuming you have a little bit of coding and a little bit of ML experience under you, internships. I'm not sure, perhaps Stephanie or you, Peter, know better, but I know that in mathematics, there's a program called the MSGI fellowship program that's administered by ORISE. And the purpose of that program is to get mathematicians into the national lab system. And a lot of the internships and research projects as part of that program are ML AI focused. And so if you can find similar programs for physicists, if you're a graduate student, so programs whose purpose is to take a physics graduate students and who don't necessarily have ML or AI expertise and embed them into industry or into the national lab. That's great. There are programs like that out there. Find those programs and really work those programs.
Great. And lastly, Richard, final advice, specific things, resources, or practice that you think an early career person should embark on?
Sure. Yeah, this is a big one. Thank you for allowing me to chime in on this one. Yeah, if there's anything I could really lend to the audience here, and I really hope I thank you for having me, and I really hope that you take this away. But because of the fact that in academia there's a very kind of standard process, there's a standardized process of kind of paths and how interviews are happening, and you apply for positions, etc. It's very different in industry. There's just so much variation that people that are interviewing, they have to standardize things to kind of figure things out. And because of this, there are very well defined certain, especially if you're going into tech. Like lead code is a tool that I suggest strongly. Lead code a lot. I guess I also want to mention, don't underestimate how much time and effort it will take and how much preparation. You really have to try to compete with everyone else that's trying to get these jobs too. And it's not easy. Just kind of wanted to give a realistic view on that. And then also try to find communities, try to find other people like you that are also doing something like lead code or are preparing in some way. It helps to find community, especially if you look online as well. And for think about where you might want to go. Like if it's a consulting route, for example, there could be like groups at your universities that are doing business case studies, for instance, and just get involved in that world and find out what's happening and get involved in community. And lastly, again, to really echo what Daniel said, gosh, internships, they make such a big difference. Like for people to get a foot in the door, to get some kind of experience. Like if you could manage to get yourself an internship, goodness, if there's anything you remember from what I just said, like please try to get an internship. And that's all.
Yeah, so I
if I could chime in on that one,
please.
Globally, so in the US, I think absolutely that's the right answer. If you're thinking a bit more globally, a lot of especially big companies have what they call graduate schemes. And it's kind of like an internship, but it sort of more often leads to a job at the end even. So check those out too.
Yeah, that's great. And yes, they use the word scheme not in a nefarious way, but it literally just means a system. So don't worry, everybody. Daniel, any last comments there? No, sorry.
No.
Okay. I would also say just in terms of like strategy and kind of early career strategy, because the field is changing so fast, realize that everybody else around you is asking these same questions. And we had an early career scientist at Lawrence Berkeley Lab in the Earth and Environmental Sciences area, and she just organized a seminar called AI in Earth Science. And she didn't know, so she started recruiting speakers, and then she started building this kind of community of practice. And so even no matter where you are, your ignorance, wherever you are at the stage of this knowledge, is actually a great asset because you're not alone and you're also asking good questions. just share those questions with others and organize, and you will find yourself. I think you'll find a lot of potential opportunities intersecting you if you put yourself out there this way. So you guys, panel members, thank you so much. We're going to pivot to Q&A. We've had a lot of great questions roll in, and Stephanie's going to roll through some of them. We're going to do Q&A for about 20 minutes and then wrap up. But anybody who wants to get the recording for this is recorded and available on the APS website. So let's roll into Q&A, Stephanie. What are some of the questions that have come through that you think our panelists will be able to answer well?
Yeah, well, I mean, we've had some incredible questions coming in. So I've been trying to kind of synthesize them and combine them and put them together, as well as respond to those that we have already answered, because you guys have just done a phenomenal job answering these questions. But I'm going to throw this one out there because I think this one is really cool. And it's kind of shifting us away from the career space. And again, apologize. I think there's so much valuable career information that we're all putting forward. But just this idea of, have you ever felt about AI not having a deep understanding of physical phenomenon when you're working with it? And do you think AI has this ability to uncover undiscovered physics problems? So things that we haven't necessarily tackled yet. How do you feel AI is going to continue to help us in this space of identifying new problems for us to find careers to solve?
Okay, I'm going to start with Daniel because you're on the edge with quantum computing already. I figured, like, what are your thoughts here?
Well, I've seen it firsthand. So
Awesome.
The specific research project I was working on was using convolutional neural networks to try and predict which algorithms a quantum computer would run. And we found that in sort of certain cases, the neural networks did really, really well at this task. But once we generalized to sort of more of a real world example, we trained it not on simulations, but on experimental data, they completely fell apart. And it is really because these neural networks were not learning anything. They were learning the statistics of the data, but they weren't learning anything about the underlying physics, which is what you really need to understand in order to tackle certain noise sources that you see in the real world. So that I think that's a case where, yeah, AI lacked understanding, but as follow-up work, we've sort of built that understanding into our neural networks. So we've used physics-informed machine learning to sort of guide the neural network into doing the computations that we want it to do, and the improvement is dramatic. We get better performance out to sort of multiple nines. And so that's a case where you need to use domain expert knowledge to sort of build better machine learning tools. With that being said, AI is already making discoveries in scientific fields, right? Whether it's the discovery of crystals that you brought up earlier, Peter, whether it's the discovery of sort of how proteins can fold. Although I think they're moving into trying to integrate the physics more into those models as well. But yeah, even in physics, there's some work by Mario Kren in using graph neural networks to predict sort of papers that are going to come out in the next couple of years, treating science as a social network, essentially, and that has been very successful. But also using active learning agents to design optics experiments in order to make the experience more and more efficient. So it's already happening, and it will continue to get better.
Yeah. Anybody else have a comment to share on this, Richard?
Yeah, sure. So I was working on a contract this summer for a NASA heliophysics project where I won't get into the details, but this is also an example of how AI, or rather physics, can inform AI models, and in that like physics understanding, you could think of it really as more data. So the same way that like was just described, that there was a physics informed method for structuring a neural network, that itself is data, right? Like neural networks are limited by the data themselves that they can get. So by structuring a problem in a way that should make physical sense, you can actually get a lot out of it. So for example, we knew that a particular physical phenomena in the prediction of solar irradiance from different wavelength channel inputs from the sun on this one instrument should be a linear combination of all these sensors. So we force it to first be a linear module. Then we figured out what are the contributions to a linear component of this physical measure called the irradiance. And then we put a convolutional network to do the corrections where the linear model would break down. So we were learning under what conditions the physics, the underlying physics that is a linear understanding, where that broke down. So that's I think that is something actually indeed we haven't touched on a lot in this call, but surely there are a lot of ways that bringing a physics intuition into AI and AI into physics, there's just a big interplay there that's just burgeoning at the moment. And yeah.
Great, thank you. How about another question, Stephanie?
All right. So again, shifting back to careers, if you guys, panelists, were to think of like a dream person to be in your space, what careers are going to be very powerful for our early career folks in the future? And, what would the ideal career be to go in to work alongside of all of you all? And I guess also kind of thinking about what careers, might not exist and might be replaced by AI. I know that's a burning question that everybody has. But yeah, thinking about the optimal areas for people to be focusing on in the future.
I'm going to ask Sarah first and then Nabil. Sarah, why don't you make some comments on that, given where you are now?
Yeah, I mean, like I've hired an awful lot of people, like hundreds, into various jobs across consulting and finance. I think you're in a really cool situation because everybody wants AI and nobody has experience in it.
Yeah.
So in this case, like, there is nobody with 10 years experience using ChatGPT because it just doesn't exist. So just embrace what's new and what's interesting. And I promise you there's roles out there that will snap you up if you have a little bit of experience in this stuff because most people don't have any.
Yeah. Nabil?
Awesome. Yeah, I love Sarah's comment about the 10 years of experience. I actually saw that called out on Twitter where somebody had a job description that had that written down, and clearly it was maybe a hallucination from ChatGPT. I think to our earlier discussion, it's so hard. This field is emerging in such a quick way. It's hard to tell where it's going. I think some of the things that I'm hearing folks get excited about, maybe looking into the future, are things like quantum machine learning. So bringing together some of the work that Daniel's doing at Sandia with machine learning to energize that or turbocharge that is the word I was looking for. Reinforcement learning in scientific research, things like robotic labs. There's the Matter Lab, Peter, where you are at Berkeley. There's an organization called Future House, which just launched a couple of months ago. That's supported by Schmidt Ventures, which does a lot of scientific kind of AI for discovery type work. That's also trying to create an AI scientist. So that might be something to look more into. And I think everybody's been really amazed at the power of transformers. They've been kind of inexplicably amazing and doing well across the board. So looking into things like computer vision, speech recognition, NLP, and the way in which transformers can help with that. But overall, I would say it goes back to the fundamentals, like lean in, start building your initial skill set, be curious, and I think there's going to be a lot of folks who are eager to work with you.
Yeah, Daniel, any final comment there?
Oh, I was just going to say, I think science policy is often overlooked in these discussions. If you're looking for sort of a future-proof AI job, AI policy is one of those where we're not gonna turn over policy work to the machines anytime soon.
Yeah. Okay, last comments across the board. Lightning comments, starting with you, Ray. Last advice, comments, suggestions, reflections.
Yeah, I think it's hard to predict where this field's going, right? A couple of years ago, I didn't know. I wouldn't think AI could replace, say, an artist for drawing, but here we are, right? So I don't think it's, at least for me, it's hard to predict what's going on. But I think as physicists, I think trusting your ability and education, like what you got was incredibly powerful, like in quantitative analysis and all those. It really transfer across the board, right? But as Sarah and Nabil was pointing out, be ready to embrace kind of the tools that we have. try to learn what's going on and try to incorporate that into your maybe daily research and things like that, and be aware of what's out there. I think you'll be well positioned to into the future.
Thank you. Richard, last advice.
I want to echo the fact that things are really messy right now and we don't really know where it's going, but that makes it super exciting. I wanted to encourage everyone, in case you never heard of this, Eric Weinberg had an essay which was Advice for Young Scientists, which is really old. It's like 4 golden lessons.
Yeah,
I found that link and I'll post it in the chat. I really suggest people to take a look at this. It's still true. It stands true back when he wrote it and is very true today. You need to go where there's a mess and no one knows what to do. Like that's where the most exciting stuff happens. That's where no one really knows what to do, right? And that's one piece of advice. And the second piece is, people mentioned like doing your own projects and kind of building stuff. If as you're learning, if you kind of can start to put together portfolios of things, it'll be maybe very helpful for you to point to potential employers as an example of something that you've created and you can talk about. That's the last 2 bits.
Awesome. Well, everybody, I think this was a great panel. Thank you all so much for spending time with us today. And Stephanie, thank you. And to APS for bringing these resources to the APS membership. We're going to close down for today. And Stephanie, why don't you take it away from here?
Sounds good. Thank you, Peter. And thank you all, panelists, for joining us. This has just been a really exciting conversation. APS will continue to bring industrial-based webinars to all of our members as well as audience. So make sure you keep an eye out for future webinars that are coming your way. But again, that's all the time that we have for today. We apologize if we didn't get to all of your questions, but you are always welcome to email us at industry.aps.org, and we'll definitely make sure we find the answer to your question. I also want to remind you that the recording of today's presentation will be available in 2 to 3 business days for upload. And please take a moment to complete the survey upon exiting. It really does help provide all of us feedback so that we can continue to produce content that's relevant and exciting for all of our viewers. This is American Physical Society, copyright 2023, all rights reserved. Thank you all again. Have a wonderful day.
Bye, everybody.
Thank you.
Thanks so much.
Yes, so much.
Bye. Thank you.
Thank you, guys.